Let's look at another application of differentiation. Here we want to look at curve sketching. In sketching a curve, we will follow 5 steps. In step 1, we'll determine y-intercepts by setting x equal to 0. We will find the behavior of y as x approaches plus or minus infinity. In step 3, we'll determine any asymptotes of y. Asymptotes of y are curves or lines which gets arbitrarily close to y but never touches the curve y. We will speak about asymptotes more in the examples. In step 4, we'll determine all stationary points. And in step 5, using the information in steps 1 to 4, we'll produce a sketch. So, of course, in these steps, we've assumed that y is going to be a function of x, and it's the sketch of y that we are attempting to produce. So let's look at an example. In example 8, this is example 8, we want to sketch the curve y equal to 2x cubed plus 15x squared plus 24x plus 1. So in step 1, we want to find the y-intercepts by setting x equal to 0. So we let x equal to 0. Then y is equal to, if you set x equal to 0 in the right hand side of this expression, we'll get y equal to 1. So the y-intercept is 1. The curve crosses the y-axis at 1. Step 2, we want to determine the behavior of y as x approaches plus or minus infinity. Now, when trying to determine the behavior of y as x approaches plus or minus infinity, we only need to look at the dominant term of y. So if you look at this example, there are 4 terms in the right hand side of this expression for y, and the dominant term is a term with the highest index of x. The term with the highest index of x is 2x cubed, so that's the dominant term. And we need to find what happens to 2x cubed as x approaches plus or minus infinity. So as x approaches plus infinity, 2x cubed, well, plus infinity is a very large number. So if you take the cube of a very large number and multiply by 2, it's still a very large number. So this approaches infinity, hence y approaches infinity as well. Now, as x approaches minus infinity, 2x cubed, which is the dominant term of y, if you take a very large negative number and you cube that, multiply that number 3 times, we'll get a very large negative number. And if you multiply that by 2, it's still a very large negative number. So this term approaches minus infinity, hence y approaches minus infinity. So in step 3, we want to determine any asymptotes. Now, to determine any asymptotes, we need to look for values of x that makes y undefined. In this expression for y, there are no values of x that makes y undefined, so there are no asymptotes. We will look at an example later where we will determine the asymptotes. In step 4, we need to determine stationary points. So in finding stationary points, we need to differentiate y with respect to x, and let's set that equal to 0. So let's differentiate y with respect to x first. Derivative of 2x cubed is 6x squared. Derivative of 15x squared is 30x. Derivative of 24x is 24. So we need to let dy dx equal to 0 to find any stationary points. Therefore, we have 6x squared plus 30x plus 24 equal to 0. We can factorize a 6 out from this expression. So if we do that, we'll have x squared plus 5x plus 4 equal to 0. So the product of 6 times this term is 0. So we can say x squared plus 5x plus 4 must be 0. And we could factorize this term as x plus 4, x plus 1 equal to 0. So we will get x equal to minus 4 or x equal to minus 1. So there at x equal to minus 4 and x equal to minus 1, there are stationary points. So let's determine the nature of those stationary points. So at minus 4, when x equal to minus 4, dy dx, so dy dx is on the top, the values of x, we'll write it below the line. So dy dx is 0 at x equal to minus 4. dy dx is also 0 when x equal to minus 1. So if you pick a value between minus 1 and minus 4, for instance minus 2, what will be the value of dy dx? Okay, so if we substitute x equal to minus 2 in this expression, because that's dy dx, minus 2 squared is 4. So 4 times 6 is 24 plus 24. Minus 2 times 30 is minus 60. And we have the plus 24. So the dy dx at minus 2 is negative. Considering those numbers, so it's negative. So this is negative, dy dx is negative. If we put a number greater than minus 1, for instance 0 is a number greater than minus 1 in here, in dy dx. If you substitute 0 for x in dy dx, this is dy dx. We substitute x equal to 0, we have positive 24, so dy dx is positive. So if you substitute a number less than minus 4 for x, for instance minus 5 in here, let's see what we get. If we substitute minus 5 squared is 25. 25 times 6 is 150, positive 150. Minus 5 times 30 is minus 150 plus 24. Hence we have a positive number. So dy dx is positive.